Okay, ACT class. So I know mine says quarter. This is from January though, and I don't think that's what I put next. I don't think it looks like this next in your packet. I think it looks like this next in your packet. So that's what I'm gonna do. I hope I'm right. Either way, here's what I'm gonna do next. It's called exponents and radicals. And so, have a little Jimmy Neutron fake dude right here. So the way I teach this is I use some color. I should have all my colors ready, even though I'm going to be mad at myself. See, it'll be okay. It'll be okay. 2 cubed equals 8. Okay, so this is called a base, an exponent, and it's going to equal what I call the solution. Okay, every teacher does this a little bit different, but the way I teach that we're going to do logs is we do log, base, solution equals exponent. I'm going to run out of room, so I'm just going to write EXP. So if I was to rewrite 2 cubed equals 8, I would write log, the base was 2, the solution was 8, and it would equal the exponent 3. Log 2, 8 equals 3. And I think I already did a problem with you guys, but remember we can do math, up, up, enter, and it would put this in, and we could put in 2 and 8, and it would say, yeah, it's 3. So what I usually do, let's see, down here I'm going to use pen because I need to use the back side of this. But I would say something like this. Can you rewrite this as a log? So maybe I write them out, and then you should pause them, and then you could try it yourself. So number 1 is 5 squared equals 25. Number 2, 3 to the 4th equals 81. And number 3, 7 to the x equals 100. Because this is actually what we want, right? These are just like rewrites, but this is actually solving. Okay, pause and then try it yourself. Oh, shoot, I didn't want to do that. Oh, shoot. Okay, anyways, I was going to color code them and I was mad at myself because the other side. Here we go. All right, so you're going to do log base solution equals exponent. There you go. Log base solution equals exponent. And we could, of course, double check these with math, up, up, enter. And then we would have 5 and 25 is 2, math, up, up, enter, 3 and 81 is 4. Everything's true. Okay, so our last one is solving log base solution equals exponent. So you can see this one, we have the base and solution. We're looking for this. So again, math, up, up, enter. We've got 7 and 100, and it gives me this long number, 2.3. 2.366. Let's say it round to the nearest tenth. Remember, if it's 6 or higher, we want to raise this one up, so x is 2.4. So I would just be careful of that. Now, if you've been in honors, you already did logs, and your teacher didn't teach you math, up, up, enter, the shortcut. So I'm just going to remind them real quick what they learned. You learned that if it's like this, that you can do change of base. So we would do log 100 over log 7. And here's what's magical. You could have also done natural log of 100 over natural log of 7, if you remember that. So using parentheses, we would use log. So over here is your log and natural log, in case you've forgotten. Log of 100. Oops. So I'm going to close that, and then divided by log 7. I can't mix. I can't do log and natural log. See how I still get 2 per 4? And then I'm going to do log of 100 divided by natural log of 100 over natural log of 7. Still get the same number. Wonderful. Okay, so honors, there you go. All right, moving to the back of this. I didn't mess it up too bad. Not too bad. Okay, so let's start it here at the top. Product rule says that if I have something times a log of 8 with a common denominator, common base, if I have x times y, I can add them through expansion. Okay, quotient, of course, means division. Quotient says that if there is a division, I can subtract them. I would usually have you annotate your notes like this because trying to be friends with my English people here. The power rule says that this one's kind of tough, so I hope you're watching. It says take that exponent and bring it down in front here. Okay. Change the base is what I just went through with you. Remember, we would put the solution term on top and the base term on bottom. So again, you could do natural log of solution over natural log of base, or log solution, log base, doesn't matter. And then equality rule says that if they both have log A and it's x equals y, then of course x equals y. Okay, so then what I would usually have us do is work through just a few things, and it's not on my original notes, so Miss Cooper's gonna just make some up real quick. So I think what I would usually do is like log 2 of 21 could be written as log 2 3 plus log 2 7, because 3 times 7 is 21. I usually don't make it that hard, but we would just talk about that. And so then I would say, all right, I want you to try log 3 of 5x. And I'd say you expand it. So you try it. You can always pause. That looks like a dog. Come on, Cooper. Log 3 5 plus log 3x. Right? No big deal. Okay, that's product. Let's move on to quotient. So a little bit easier to see. Log 2 of, I don't know, 5 over 7. I would usually ask you guys for numbers because look, I've already used 7 and 5. That's just what I do. I start getting in a rut. Okay, so again, we're going to take, from right here, you can see it says x over y. So we would do x minus y. So we would do log 2 5 minus log 2 7. Oh, so let's say, I have this question all the time of, Cooper, what if there is no base? Okay, well, first of all, we love that because then I just have to write log x minus log 3. Super love that. But what this means is if there's no base, maybe we put over here, if there's no base, that means it's actually 10. So I would show you in your calculator right here that log 3 is the same as math, up, enter, log 10, 3. It's a common base, right? Like 10 cubed, 10 to the 4th, 10 to the 5th, whatever. It's our common base, and so that's what it is. If there is no base, it's technically 10. And I was gonna say something else. It's the pit's getting old. Okay, so the power rule is when we have something like this, log, and I'm just gonna keep it easy, x to the 5th. So again, that 5 would come down, and so we'd say 5 log x. Okay, so here's where kind of we hit the road here just a little bit. Let's see if you can see the difference between this. log AB squared versus log AB squared. How would those write out differently? Because they're both power. They both have an A and a B and a 2. I hope you saw that both of these are squared. So really, because this is A times B squared, what we would do is we'd say log A plus log B squared, and then we would bring that down to log A plus 2 log B. This next one, there's two different ways. Some students would bring it down in front first and say I've got 2 log AB, which is 2 times log A plus log B. It's a little sloppy, I'm sorry. Or you would distribute first and you'd say, no, Cooper, I see log A squared B squared, which is log A squared plus log B squared, which is 2 log A plus 2 log, log B, which is this distributed, right? I could distribute that and say 2 log A plus 2 log B, same thing, all the same things. Okay, so then after that should be this ACT practice problems. Let's work through these like we have before. So we've got 1, 2, 3, 4, 5. So I would say try these left hand. Let's try for 3 minutes and to get 3 correct. Pause, please. Okay, so you guys should have said number 1. Oh, I gotta work through it. Right. I usually just give answers right then, but obviously on the camera, Cooper. Okay, let's see here. Gonna have to use pen. So I've got that this weird statement, right? This is A, B, C, D. So I'm gonna label these as A, B, C, D. So it says to do A times C, that 2 times 3 plus B times D, 1 times 4 over A times B, A times B, 2 times 1 minus C times D, 3 times 4. So 2 times 3 is 6 plus 4, and then I've got 2 minus 12 is 10 over negative 10, which is why it's negative 1. The next one is tricky because it says what must be added? Something must be added to x squared minus 2x plus 6 so that the sum is 3x squared plus 7x. I have lots of students that put the answer A because they added these two together, x squared and 3x squared is 4x squared. But that's not the answer. It's saying what should be added to this. So that means I'm going to have to subtract it. So I've got this x squared. Oh, sorry, 3 minus 1 is 2x squared. So we know it's none of these either. So it's going to be one of these. This is a positive 2x. I'm going to add 2x. So 7 plus 2 makes 9x. So it must be this guy. And then again, it's a plus 6, so minus 6. So that's why it would be D. Moving on to number 17, it says that we have a line segment with endpoints. Oh, do you remember we've already done a midpoint, but this time they gave us the endpoint and said, what's the middle? So it's always on the ACT test. It's either going to give you the midpoint in one point and ask for the other, like our first time, or it's going to be like this, which is much easier, right? We said that we would take the first points, the 3 plus x, sorry, it's over here, x1 plus x2 over 2, and then y1 plus y2 over 2. That's an equation you're supposed to know. So I take these 2 x points and divide by 2. So 12 over 2 is 6. Okay, so then our y point, we're expecting either a 2 or a 5. So I've got 6 and 4 over 2. 10 over 2 is 5. Perfect. Moving on to this next one, it says that we want an equation. So back when you were a freshman, what we would do is we'd find the 0 point. That is our y-intercept. So it's y equals mx plus b, where m is our slope and b is our y-intercept. So we would say it needs to start with plus 10. Okay, and then right here we can see it's moving by 4s, so that's its slope. And so that's why our answer is C. There's a lot of different ways you could do it, but that's the fastest way I know. And then do you remember we talked about this? If we're going to increase a mean by a certain number, we can multiply these together, and so 4 times 2 is 8. Okay, so we've done the left side. Okay. And then on the right side, we've got 4 questions. Again, I would suggest you do it 2 minutes timed and you're trying to get 2 correct. And go. Okay, hopefully you did that. So number 14 says that we have a bag of 400 jelly beans and 25% of the jelly beans are red. So I would just ask you guys, and you'd be like, how many is it? That's 100. So this is what I envision. I've got 400 jelly beans, 100, 100, 100, and 25% of them red. It says, if you randomly pick a jelly bean from the bag, what's the probability that is not one of the reds? Well, we've got this other 300 out of 400, which of course is 3/4. Real quick though, I know you guys already know it, but 300 divided by 400, you can hit math, enter, and it will reduce that fraction for you if you don't know that you can just take away the zeros. Ooh, once again, you guys probably know how to do this by hand. You say that's negative 21 plus 8. And so you would get that that's absolute value of negative 13, which is, of course, positive 13. But I want to remind you that you can do math, right, enter. Math, right, enter. And that you can just put it in. So do 7 times negative 3 plus 2 times 4. And when we're doing the ACT, guys, we just want to do it as fast and as correctly as possible. So yes, this is fast, but what if you make a mistake? I don't know. Anyways, okay, right here, it looks like we're going to do a substitution. Negative 3 squared minus 5 times negative 3. And again, I would put that straight into my calculator. 4 times negative 3 squared minus 5 times negative 3. And I get that it's 51. Number 27, Mrs. Jones, John's wife, is very nice because she's letting him invest $10 million. And then it's going to cost them $7,000 to produce a boat. They are losing a boatload of money. Oh, Mrs. Jones, you're so sweet. But it says right here that we have a selling price of $20,000. So that's kind of a changing point, right? So we've lost money. Investing is losing money until you gain it back. Cost is losing money until you gain it back. And then the selling price is $20,000. So that's a profit. Well, that's making money, but we're trying to find out, when does he start making money? Well, these two are per boat, so that 20,000 take away that 7,000 means that it's a profit of 13,000 per boat. Okay, but only after you make up that 10 million. Ooh, bless you, Mrs. Jones. All right, moving on to the back, we have 6 questions. I'm going to do them all at once. So how about you take 3 minutes and try to get 3 correct. Let me give you a minute. Oh, I get to use markers. Okay, so looking right here, I've got 2x squared plus 6x equals 36. I had suggested that you move that over. Remember how we talked about how you don't need to factor this. You just need to be able to put it into a calculator, which means I can put it equal to 0. And so I'm going to go to my y equals. I'm going to put in this equation, 2x squared plus 6x minus 36. And I'm going to hit graph right here, graph. And you can see it crosses at -6 and +3. Done. That's great, but it has to be in that ax squared plus bx plus c equals 0 form, right? So you have to do that, then you go to right here, y equals, you plug it in, you hit graph, and then you see where it crosses the x-axis because it says, what is x? I'm going to go straight down. Here's my log stuff again. So it says, which one is this? So we could put it in. I'm sorry, that was very loud. Math up, enter. We could put in our 2 and our 8 and know that it's 3, just like we did before. This one's interesting. It says, which of the following expressions has a positive value for all x, such that x is greater than 0? So again, we've talked about this, like just pick a number. Usually Samantha's in here. I'm gonna pick 4. So I'm gonna say x is 4, something less than 0. I don't want 4 and I don't want 1. I'll go with -2. Let's see what happens. So I'm going to do -2 minus 4 is -6. What am I? Has a positive answer. Nope. X is 4 plus -2. That's a +2. That's a maybe. Cubed. So 4 cubed times -2. It doesn't matter what it is. It's going to be something negative. Oh, I'll do it. 4 cubed times -2 is -128. But I knew it's going to be negative because of that little negative right there. Not you. Okay, then we would have 4 squared over -2. 8 over -2 is going to be a -4. But because that was negative, I knew that that was not going to work either. And then right here's the gold. Because it's 4 times -2 squared. Anything that's negative, that's squared, is always going to be positive, and so that's why that one's the correct answer. Although this one could have worked, had I changed numbers, it would always work. Because if I would have picked -6, then that would have been 4 plus -6, which would have been a negative number. Okay. Everybody hates fractions. They know you hate fractions, so they're going to put fractions in there. Don't be scared. Put it into your calculator. 5/3 is 1.6 repeating. 7/4 is 1.75. 6/5 is 1.2. And 9/8 is 1.125. So it's asking us, we gotta know that means less than, right? So the least is 1.125, is less than 1.2, is less than 1.6, is less than 1.75. So 9/8 is less than 6/5, is less than 5/3, is less than 7/4. So I'm gonna look for 9/8 first, and then 7/4 at the end. Ooh, magic. This is in your calculator. I is second decimal. So I'm gonna walk you through this. It says, parentheses 4 plus, and then I want the I, so I'm gonna hit this second button and this decimal button. See the I right there? La. And then you hit squared. Boom. It does it for you. All imaginary is done in the calculator. Please don't take your time. Oh, but Miss Cooper, I want to remember how we did it. Okay, here we are. Remember how we did 4 times 4 is 16, plus 4i, plus 4i, plus I squared. And you had to know that I squared is -1. And so 16 plus -1 made 15. And then your 4 plus 4 made 8i. Dang it, I didn't use markers. I'm so mad at myself. Anyways, that's how you do it. Last one. For which numbers would this be true? Is it always true? Oh, let me pick a number. I just use 8, so let's try that. Is 8 plus 8 equal to 8 minus 8? Of course not. 16 is not equal to 0, so it's not always true. What if A equals B? No, that didn't work either. What if they're both and 0 plus 0, is that equal to 0 minus 0? Well, yeah, but that's very restricting. They both have to be 0. D, well, so it's not never, right? Because we know zeros work. So now it's between these two fancy words. And means very restricted. They both have to be zeros. D says or, either A or B, meaning I can do 8 plus 0 and 8 minus 0. That's 8 equals 8. That works. Let's try it the other way. 0 plus 8, 0 minus 8. That's 8 and negative 8, but the absolute value means it's still 8. So what's amazing is I could change that to 18 and it would still work. So this is the least restrictive. Although C works, it's more restrictive than D. Okay.